Alright, let's deal with some of these quickly. 4.1. Here we have something multiplying by something equated to 0. Okay, so let's put that again. We have something multiplying with something and their product is 0. When you have two things multiplying and their product equals 0, one of them must be 0. So that means either this one is 0. So if A is 0, it doesn't matter what B is, because 0 times anything equates to 0. Similarly, if B is 0, it doesn't matter what A is going to be, the whole thing equals 0 because they are multiplying, right? So what you have here in the question above, let's get rid of all of this. You have something and it multiplies with something else. So let's take this first thing over here, which is our x minus 1. Maybe that is 0. Or the second thing that you have there, right, let's put it over here, x plus 2. Maybe this one is 0. So one of them needs to be 0 in order for the entire left hand side to generate a 0. So now we can simplify this. We add 1 on both sides, so x is equal to 1. Simplify this, subtract 2 on both sides, so x is equal to negative 2. Those are our two solutions over there. Right, now that was quick, that's great. Let's try and go into the second one as well. Okay, so make sure you, whenever you see the square, the quadratic, right, what you want is you want everything on one side equated to 0. So your 81 over here, let's bring it over to our other side. So we'll have x squared minus 81 on both sides equals to 0. Okay, and what you should notice now is here's a negative. This is a perfect square. This is a perfect square. So this is the difference of two squares. What do you do when you have a difference of two squares? You make your two sets of brackets. This is equated to 0 now. Okay, so different to when we factorized, in that this part is here now. So that just means when you are done, once we factorized, these two will generate solutions. So there's just extra steps to what we've already dealt with. Okay, so let's get back to the difference of two squares. Two sets of brackets, the square root of the first one, so x and x, square root of the last one, so 9 and 9, and then a plus and a minus. Right, so our two brackets will have to equate to 0. So either x plus 9 is 0 or x minus 9 is 0. Okay, so let's manipulate this. Subtract 9 on both sides. So one of our solution is x equals minus 9. Add both sides over here. So add 9 on both sides. So x equals positive 9 on our right hand side. Okay, x equals our positive 9 on the right hand side. Okay, that was also quick. Let's do the third one as well. Right, we'll spend a little bit more time on this one because this one requires advanced trinomial, which we haven't discussed yet. There's our advanced trinomial. Still just basically a trinomial. But when we say it's an advanced trinomial, we are saying that this number in front of the x squared, it's no longer a 1. It's a different number. In this case, it's a 5. So when you deal with your advanced trinomial, you are going to look at your first value here, which is your 5. You look at your constant, which is your 27. And we're going to write down the factors of both of them. And let's start with the 5. The factors of 5 is 1 and 5. And we're going to double up on one of the sides, okay? So I'm going to write 1 and 5, but I'm also going to write 5 and 1. And then the factors of 27, that's 1 and 27. 2, no, 3 and 9, for nothing else, right? So those are all of the factors of 27. Right, the reason we said we double up, so 1 and 5, 5 and 1, one of my sides, so either the side or the side, I double up my values. The reason we double up is so that we can cover all possibilities. Okay, if you don't double up, you might lose your solution, you might not find the answer. So make sure one of your sides you double up. The reason I chose my left hand side is because there's less factors over there. There's only two factors. So when I doubled this up, I only had to write two things. If I doubled at my right hand side, it would have been 1 and 27, 27 and 1. 3 and 9, 9 and 3. So there's just more stuff to write if I doubled up my right hand side. I could choose to double it up, but I doubled up my left hand side simply because there's less numbers there. Great, let's move on. Okay, so once you've written out your factors as we've done over here, now we're gonna multiply across and we're gonna see if we can find our middle term. What I mean when I say that is like this. This one, I'm gonna multiply with that 27. 1 times 27, still 27. This 5, I'm gonna multiply with 1. All right. And now these values I'm gonna add or subtract to see if I can get my middle term. My middle term is that 24 there. So 27 and 5, if I add those, I get 32. 27 and 5, if I subtract those, I will get 22. So this pairing, this combination can either get me 32 or 22. Is that my middle term? It's not my middle term. So as much as that pairing is a possibility, that's not a possibility that gets me my middle term. So I'm gonna scratch that. I'm gonna get rid of all of that. Let's try the next one. So I'm gonna say the 1 times the 9. 1 times 9 is still 9. 5 times 3, 5 times 3 is 15. So if I add these, I end up with 24. Okay, if I subtract those 9 and 15 and I subtract those, I end up with 6. So the pairing that we have, they can either get us a 24 or a 6, positive or negative, right? And we look at our middle term, it's a 24. So yes, that pairing works for us. So the values we're going to choose is the 1 and the 5, the 3 and the 9. Okay, so let's just, before we move on, take a second and figure out what just happened. Okay, what we did was we took this one and we multiplied it with that 9 to give us this 9. We took this 5, multiplied it with this 3 to give us this 15. Okay, then we looked at these values that you have over here. We added them together and it gave us this 24, because this 24 is that number. Thus, these values that I've circled are the ones that will work and give me this trinomial. Great. All right. So this is what we'll do now. We're going to write our brackets. Trinomial, so we have two sets of brackets. And this one is equal to 0. So don't forget to say this is equal to 0. So when we go back here, these factors on our left hand side, right? These values, they came from your A. So this 1 and 5, they make up that x squared term. So the 1x, there's invisible 1 there, and the 5x, they multiply to give me my first term. Okay, so the 1 and the 5, they went first into my bracket. Now this 3 and the 9 need to be the next values. So maybe the 3 goes there, maybe the 9 goes there, or vice versa. Now we need to decide. So we're going to go back to this thing over here. And the way we decide is the 1 multiplies with a 9. Because the 1 multiplies with a 9, so, okay, let's just take a second quickly. If you multiply out, this x multiplies with that one, this x multiplies with that one. Whatever here is multiplies with that one, whatever this is multiplies with that one. So this x that you see here, it multiplies with everything in your second bracket. Okay, why am I saying this? The reason I'm saying this is because this x here has the 1. The 1 has to multiply with a 9. So the 1 and the 9 have to be in opposite brackets. Right? The 1 and the 9 must be in opposite brackets. The 1 is here. So the 9 will have to go over there. Let's clean this up a bit. Right, so we've got our 9. So obviously the 9 is there. The other value was a 3. So the 3 will have to go there. Right? And the last thing we have to do is decide on our signs. So in order to decide on our signs, we're going to go look back at this. How did we get out 24? Positive 24. The 9 had to be positive and the 15 had to be positive. Right? Where did the 9 come from? It came from this one multiplied by that one. They have to generate a positive value, so both of them have to be positive. The 15, where did the 15 come from? The 3 times the 5. So they have to give me a positive value, and this will have to be positive so that both of them can be positive. Okay, so we've factorized our advanced trinomial. Another step, because this is equated to 0, this will generate a solution, this will generate a solution. So we'll say x plus the 3 equals 0. Okay, we'll subtract 3 on both sides. So our first solution is x equals -3. And we'll say 5x plus the 9. All right, let's write this nicely. 5x plus 9 equates to 0. Subtract 9 on both sides. So 5x equals to a -9. Divide both sides with 5 to get rid of your 5. So x is equal to -9/5. Right, that was our advanced trinomial, which is in an algebraic equation equal to 0. So we have our two solutions.